Today we are going to cover section 11.2, Introduction to Relations in Functions. So take the time to write down your title, your essential question, how do you use interval notation to write solutions. Go and paste your card or copy it down, and we'll start once you are ready. Go and pause it. So section 1.2, how do you use interval notation to write solutions? So we have a set builder notation, which is as follows. X, all the values of X, the little bar is, do you remember how we pronounce that? That is X such as. All the values of X that are greater than A. And to graph it, we are going to place A in the center. 0 can be on the left or on the right. We know the positive infinity, all the numbers to the right are greater, so therefore this is positive infinity all the way to the right, and on the left we're going to write down negative infinity. So this is the solutions are all the values of X, such as X is greater than A. It's greater, so therefore we're going to place an open circle. It's not equal, so we're going to leave it as open. And all the values that are greater than A are to the right. So that is how we graph this notation. All the solutions are all the numbers to the right of A, but not including A. Now to be able to write down a interval notation, it's from A all the way to positive infinity. We're going to place a comma in between. Now it doesn't include the value of A, so therefore we're going to leave it as open. So where you used to have an open circle, we're going to have a parenthesis. Infinity, you can place a positive infinity in here, or we can just leave it as infinity, which is positive. Infinity always gets a parenthesis. So let's go to the next one. The solutions are X, such as X is less than A. Once again, we're going to place our A in the middle, positive infinity to the right, negative infinity to the left. It's less than is not equal to, so we're going to leave it as open. And all the values that are less than A are to the left. So therefore, we always start with the lowest number. It's going to be from negative infinity all the way to A. So therefore, when you write it down, it will be from negative infinity. Remember, infinity always gets a parenthesis, comma, A, not including the values of A since it's open, so therefore we're going to place a parenthesis. Infinity, we never reach infinity, so therefore we always leave it as open as well. So you can get closer and kind of further away. Well, we'll have a discussion on infinity on chapter 13. The next one, we're going to place A at the center. So the solutions are all the values of X, such as X is greater or equal to A. It's equal to, greater or equal to, so therefore it's going to be closed. Infinity, negative infinity to the left, positive infinity to the right. And all the values that are greater or equal to A are to the right. It'll be from A all the way to positive infinity. Now, in this case, we are including the value of A, so we cannot place parentheses, we need to place a bracket. So whenever it includes the value, we are going to place in a bracket on the A. We never reach infinity, so infinity always gets a parenthesis. So therefore, if it's open, we are going to place a parenthesis. If it includes the value, if it's close, we're going to place a bracket. For the next one, all the values of x, such as x is less than or equal to a, we're going to place our a in the middle. In this case, it's including the value of a, so it's going to be close. And all the values that are less than are to the left. Negative infinity is on the left, positive infinity is on the right. So therefore, it will be from negative infinity all the way to a. Remember, infinity always gets parentheses. A, it's including the value of a, so therefore it gets a bracket. For the next one, we have all the values of x, such as a is less than x, which is also less than or equal to b. So therefore, this is what we call a compound inequality. So to graph it, we're going to place a and b. We're going to place a on the left, b on the right. On the a, it's not including the value of a, so therefore it's going to be open. On the b, it's including the value of b because of the equal sign, so it's going to be close, and all the values in between. Remember though, in this case, we can say x is greater than a, which are all the values greater than a are to the right, and x is less than or equal to b, which are all the values on the left. So when you read this, you have to read it backwards. So in this case, it's all the values from a to b. It includes b, so therefore b gets a bracket, but it does not include a, so therefore a gets a parenthesis. And for the last one, once again, we have a and b, so we're going to place a on the left, b on the right. So all the values of x, such as x is less than or equal to a, or x is greater than b. In this case, a is included, so we're going to close it. B is greater, is not equal, so we're going to leave it open. All the values of x that are less than or equal to a are to the left. All the values of x that are greater than b are to the right. This is negative infinity, positive infinity on the right. So therefore, we're going to write down as two separate notations. It'll be from negative infinity all the way to a, where infinity always gets a parenthesis, a will get a bracket, because we do include the value of a. Then from b all the way to positive infinity, and if you want, you can place a little plus in here, where b is not included, so we place parentheses. We never reach infinity, so we also place parentheses. And in the middle, we're going to place a union. So the u will be union. A union of both sets. So now let's go through example number one. We are going to start solving simple inequalities. Go and copy it down, and we'll start once you're ready. Go and pause it. Solve. Then graph the solution and write in interval notation. So first we're going to solve it, and these are simple inequalities that you guys have seen back since algebra 1. Now, you can add 5 on both sides. You can do plus 5 or plus 5, but just for my purposes, to be able to speed up the process, I'm just going to move things left and right, because that's going to be very helpful as we move on to more challenging problems. It's negative 5, so we can say positive 5. Or you can do plus 5 and plus 5. So therefore, we have 3x is greater or equal to 12. I need to be able to leave the x by itself. The 3 and the x are multiplying, so I'm going to divide. So we're always doing the inverse operation. So we're going to divide by 3 on both sides. Most of the time, I won't do the divide by 3. I'll basically just say x is greater or equal to 4. At this level, we're going to just do a little faster. And that is my solution. Now I need to graph it. I'm going to make sure that you guys are using a ruler to graph your solutions. Just going to do a quick number line. I need 4. I always want to place my 0 so I know my reference. So this is going to be, I need 4 spaces. I'll place a 0 here. And 1, 2, 3, 4. You don't need to write down all the numbers, but I do need to place a 4 in here. It's going to be closed. And my solution is all the numbers that are greater or equal to 4, so therefore will be to the right. So now go ahead and write down a interval notation, just like we did over here, and see what you get. Go and pause it. Excellent. So in this case, is my negative infinity is to the left, my positive infinity is on the right. So therefore, it'll be from 4 all the way to positive infinity. Remember, you always want to place the smallest number first, which is 4, all the way to positive infinity. 4 is close, so therefore it gets a bracket. Infinity we never reach, so therefore it gets a parenthesis. All 3 of them represent the same solutions. Letter B. I need to be able to leave the x by itself. Go and solve for x, graph it, write it down in interval notation, and then we can compare our answers. Go and pause it. Excellent. So in this case, I'm going to move my 7 to the right. It's a positive 7, so I can just minus 7, or I can do minus 7 on both sides. I end up with negative 2/3. X is greater than negative 3. And now to solve it, I can do it in 2 steps. I can multiply both sides by 3 to get rid of the denominator, or I can just multiply by the reciprocal. So that is negative 3 over 2. So therefore my 3 cancels, my 2 cancels, negative negative is positive. So therefore x. But do you remember what happens when you multiply by a negative number when you have an inequality? You have to flip the inequality. So if it gives you negative negative is positive, so it'll be 9 over 2. And this will be my solution. We can leave it as a mixed fraction. We can also change it to, we can leave it as an improper fraction. We can change it to a mixed fraction. Just make sure that you are careful with the instructions on your textbook. And now I just need to graph it. So let me place a quick number line. I'm going to place my 0 here, since this is 4 and 1/2. 1, 2, 3, 4. This will be 9/2. This is 5. So therefore, this is going to be open or close. It's going to be open. And all the answers are, all the values are less than 9/2 are to the left. This is negative infinity. This is positive infinity over here. So therefore, it'll be from negative infinity all the way to 9/2. Negative infinity always gets parentheses. It does not include 9/2, so therefore it also gets a parenthesis. All 3 solutions, all 3 representations are representations of the solutions. Example C and D. Go and copy it down, and we'll start once you're ready. So this is what we call a compound inequality. A compound inequality is when we have 2 inequalities that are together or within the same problem. They can be in OR, but when they're connected, these ones are called a AND. In this case, the second one is in OR. To solve it, instead of just having two sides, I have three sides. And our purpose is to be able to leave the x by itself in the middle. So therefore I need to get rid of the 5. So you can add plus 5, plus 5, or plus 5. For my purpose, I'm just going to move this 5 to the left and to the right. So plus 5, plus 5. That gives me 12 greater than 2x, which is greater than 6. I still need to leave the x by itself. It's multiplying by 2. The 2 and the x are multiplying, so therefore I need to do the inverse operation, which is to divide by 2. That'll give me 6 is greater than x, which is greater than 3. Now, most of the time we prefer to write down the smaller solution on the left. So therefore I'm going to place my 3 here, my 6 on the right, my x in the middle. The greater stores the x, and the greater stores the 6. So those two expressions are equivalent. And now I can graph it. I'm going to place a number line. It's just a quick number line. This is 0, 1, 2, 3, 4, 5, 6, and 7. So notice that on my 3, I have an open or close. It's open. On my 6, it's also open. And to graph it, we need to read this backwards. X is greater than 3, so all the numbers that are greater than 3 are to the right. And x is less than 6, which are to the left. So therefore, whenever you have it connected, whenever it's an and, your graph should always be connected, since it's an and. And to graph, so we solved it, we graphed it. Now we're going to write down in an interval notation. So be the numbers from 3 all the way to 6. And notice that they both give a parenthesis. Since it does not include the 3, it does not include the 6. Letter D. Whenever you have an OR, they should be separated. There's some textbooks that will make different rules, but for the most part, ORs will always be separated by OR. And we're just going to solve each one separately. So solve the first one, solve the second one, and then we can compare our answers. Go and pause it. So in this case, I'm going to solve the first one. Move my 5 to the right, it becomes a negative 5. That gives me 3x is less than negative 11. I'm going to divide by 3. So therefore that gives me x is less than negative 11 over 3. On the second one, I'm going to move my 3, becomes a negative 3. Or minus 3 on both sides, whichever you prefer. We have negative x is less than 2. I'm going to divide by negative 1. So therefore that gives me x. And when I divide by a negative number, I have to remember to flip my inequality. That gives me negative 2. That gives me a negative 1. So I got the mistake, so that should be a positive 1. Negative 1 divided by negative 1 is positive. And now we can graph it. Let's see, negative 3/3, no, it's in negative 11 thirds. Negative 11 thirds, that'll be 3 and 1 and 2/3. So therefore, I need 1, so I'll place my 0 here. This is 1 that I need. Negative 1, negative 2, negative 3, and negative 4, negative 2/3. Sorry, so it'll be negative 11 thirds. So we can rewrite negative 11 thirds as negative 3 and 2/3. So therefore it's going to be open here, and it's going to be open as well. All the values that are less than negative 11 thirds are to the left, All the numbers that are greater than 1 are to the right. So one of the things that you notice is that whenever it's an AND, they should be connected. Whenever it's an OR, they should always be going away from each other. So it's something that you need to be able to remember for the test. AND, connected, smaller value on the left, bigger number on the right. Your graph should be connected, and this should be your interval notation. Whenever we have an OR, automatically they should be going away from each other because it's one way or another. And when we graph it, there'll be two parts. Now, many of you guys will get this wrong on the test. So just make sure that you pay attention to when, or just memorize when's an AND or an OR. And somehow students have difficult time writing that notation from negative infinity all the way to negative 11 thirds. 9 colon 11 thirds will be parentheses. Then from 1 all the way to positive infinity. 9 colon to 1, so therefore it gets parentheses. And in the middle it gets a unit. So this is something that people have difficulty. They graph it correctly, but somehow they can't write the interval notation correctly on the test. Functions. So let's go over functions. You guys cover functions back from Algebra 1. Go ahead, copy or glue your cutout. Example number 2, A and B. And C, D, and E. Go ahead and pause it, and we'll start once we're ready. So the definition of function. A function is a correspondence in which each element x from a set called the domain is paired with one and only one element from a set called the range. So the key thing is that your element x, it's paired with only one and only one element y, with one and only one. If you guys remember, we're talking about your domain and your range. So we have, if we have a point, x and y, your x is your domain, and your y is your range. So each x can be paired up with only one and exactly one y. So decide whether each relation defines a function. So we have 5 different relations in here. I need to decide if this is a function. So therefore we are going to be looking at the values of x. A negative 3 is paired up with a 0. A negative 4 is paired up with a 0. And a 3 is paired up with a 2. So in this case, each x, there's only one x. There's only one negative 3, only one negative 4, and one 3. And even though this negative 3 is paired up with a 0, and this negative 4 is paired with a 0, it's still fine. The only problem that you're going to arise is whenever you end up with two x values that are paired up with different values. So this is a function. So we are concentrating on the values of x. The 2 is paired up with a 3. The 3 is paired with a 2. And now the 2 is paired up now with a different number. So therefore, not a function. You cannot plug in a 2, then get a 3, then plug in a 2 again and get a different number. So the example that I usually use when I teach Algebra 1 is that if I'm going to just make up an equation, y equals 2x plus 1. You cannot plug in a 2, get a 3 the first time. So if Mike plugs in a 2, and Mary plugs in a 2, then who is correct? Well, let's both plug in a 2. So plug in a 2, Mike gets a 3, and Mary gets a 5. Can they both be correct? No. In this case, who's correct? Mary. So therefore, you cannot plug in a 2, get a 3, then plug in a 2, and get a different number. So that's why the reason that that's not a function. Letter C. 1 is paired with a 2, negative 2 is paired with a 4, and 3 is paired with a 4. Is that a function? Yes or no? Yes, that's correct. That is a function. Two x's can point to the same y value, just like we have here. And sometimes it might be easier to write down as a point. 1 corresponds to a 2, negative 2 corresponds to a 4, and 3 corresponds to a 4. So that is correct. Letter D, we're just going to be looking at the x values. Is that a function? Yeah, that's a function. None of them are repeated. Letter E, is that a function? No, not a function. And why not? So in this case, the negative 4 is paired up with a 1. Then the negative 4 is now paired up with a 3. You cannot plug in a negative 4 twice and get different y values. And the last is negative 2 is 7. So in this case, that is not a function. Now let's look at in a graphical manner. So in this class, you really need to be able to understand your algebraic aspect. You need to be able to understand why it's not a function in algebraically and graphically in order to be successful. We have, go ahead and copy or paste your cutout. Same thing with example number 3. Go ahead and pause it, and we'll start once you are ready. If every vertical line intersects a graph in no more than one point, then the graph is the graph of a function. So every vertical line can intersect no more than one point, only at one point, in order for that to be a function. So in algebra 1, you guys looked at the vertical line test. So if you make a vertical line, and I'm just going to use this. Can any of the vertical lines that you can draw, how many times they intersect? Once. How many times it intersects? Once. But in here, it intersects twice. So therefore, this first letter A is not a function. And if it's not a function, if you can do me a huge favor, just draw a vertical line. And in this case, this point is 1, negative 1. This point is 1 and 3. We cannot have two x values point to we cannot have an x value point to two different y values. Right? We cannot plug in a 1, get a 3, then plug in a 1 and get a negative 1, if it's a function. Letter B, is that a function? Yes. If we draw a vertical line anywhere, it only crosses once, once, once every single time. So therefore, that is a function. For the next one, is this a function? And do you guys remember what the little dash line is? The little dash line is and asymptote. And we'll cover that. You guys covered this on exponential functions, and we'll cover that on chapter 2 or 3. So in this case, is this a function? Yes, this is a function. And is this a function? Yes, it only crosses one. Now, if the graph was this way, then that would not be a function because it crosses twice. But in this case, we have a nice parabola that's facing down, so therefore this is also a function. But we also need to be able to find the domain and range. Remember, your domain are your x values, your range are your y values. So in this case, I'm just going to place a D in R for domain and range. So the domain, well, this is not a function. I'm still going to write down the domain and range just for practice. We can still find it. So in this case, your x values are just specific values. So your x value for this point is -2, and we're going to place it as a set notation, or be from -2, comma, this is -1. Both of those points have a 1, so we're just going to write down 1s. Your range are your y values. So in this case, we're going to start with the smallest one, which is -1. For those 2 points, the y value is -1. Then we have +2 for this point. And for that point, your y value is 3. So make sure you place braces at the beginning and at the end. And this is called a set notation, similar to what we have on the cutout. The only thing that we're just not doing is the such as. Function, domain and range. So in this case, what is the domain for this graph? So notice that if I'm working on my x-axis, so if I'm working on my x-axis, I see a graph below. So even though this one starts here, we know that it continues beyond. So it'll be from -infinity all the way to +infinity. So from -infinity all the way to +infinity. Or you can say all real numbers. Your range. What are the appropriate values for the y's for this graph? Notice that if we start for the lowest value, we know this graph here all the way to beyond. So it'll be from -infinity all the way to +infinity. The domain and the range. So see if you can find the domain and range for the following graph, and then we can compare. And same thing with letter D, the domain and your range. So for letter C and for letter D. Go and pause it, find the domain and range for each one, and then we can compare. Excellent. So in this case, your domain. So in this case, if we start walking on the x-axis, there's a graph below us. So all the values that we can plug in for x, so it'll be from -infinity all the way to +infinity. And for range, we start at, from the lowest value, the graph starts at -1 all the way to +infinity. +infinity gets a parenthesis. -1, we never reach -1 for the y value. So therefore that one gets a parenthesis as well. For letter D, domain, we know that the graph continues going further down, so therefore it'll be from -infinity all the way to +infinity. And your range will be the y values. We know the graph goes beyond all the way to down to -infinity, so it'll be from -infinity all the way up to 2. And we are assuming that it reaches 2, so therefore it gets a bracket. Example number, so in this case, let's actually go back. You do need to be able to be careful, and you do need to understand your domain range. You need to be able to understand that domain are all the values that you can plug in for x. That will give you a graph. And your range are the y values that we get back. So domain are your x values that we can type into an equation or enter or substitute an equation. And your range are your corresponding y values that we can get back from a function. So in this function, we can never get back a negative 2 as the y value. On this function, we can never get a 3 back on this function. So domain are your inputs, range are your outputs. So something that you want to make sure that you understand for this, since you've seen it in Algebra 1, you've seen it in Algebra 2, and now the third time, pre-calculus. Go and copy example 4, A and B. Go and pause it, and we'll start once you're ready. So given the following function, find f of 3. So this is your x that we need to plug in here. So now we have equals negative 2, the x plus 1. But now instead of the value of x, they're telling us to plug in a 3. So it's just a quick substitution. And now we're going to simplify. That gives me a negative 6 plus 1 will give me a negative 5. F of 3. Now this is a notation that you want to get used to. And what's nice about this notation is that this represents a point. This is, you type in a 3, you got back a negative 5. So this is your y value, and what you typed in is your x value, or what you substituted. So in this case, they tell you the value they plugged in and the corresponding y value, which represents a point. Letter B is one that you guys will get, or many of you guys are going to struggle throughout the year, just the notation. So in this case, they're telling you to find the value of x if f of x is equal to 3. So if the value of y is 3, we're looking for what is the value of x. So therefore, we are going to substitute. Instead of the x, we're looking for x, correct? So they're telling us that f of x, which is the y, remember that whenever you see this notation, you need to be able to see it as y equals negative 2x plus 1. Those two expressions are equivalent. They're the same graph. This is the y, that's the y value. This is a function notation. So therefore, f of x is 3. So instead of f of x, I'm going to write down a 3 is equal to negative 2x plus 1. And now I'm looking for the value of x. So move the 1 to the left, we can say negative 1. That gives me 2 equals negative 2x. Divide by negative 2 on both sides, so therefore x equals negative 1. And this represents a point as well. Your x value is negative 1. Your y value is 3. But notice that having it written down in this notation, we can actually write down as f of negative 1 is equal to 3. In this case, our answer is x equal to negative 1 because we're looking for the value of x. But be careful, many of you guys will get that type of question incorrect. We'll practice a bit more before the test. C and D. Go and copy it down. We'll start once you're ready. Go and pause it. So this tells me that I need to substitute, instead of the x, I'm going to replace it with 3x. So therefore, I'm going to continue using my same function. equals -2 instead of the x. I'm going to replace it with 3x. And I'm going to simplify. That gives me a -6x plus 1. Nothing else to simplify, so therefore that will be my answer. F of 3x is equal to -6x plus 1. You guys covered this type of problems when you guys cover composition back in algebra 2. Letter D. Try and see what you get. And pause it. So in this case, this tells me that I just need to replace the x with h plus 1. So therefore, it will be -2 instead of the x. I'm going to replace it with h plus 1. That will give me a -2h minus 2 plus 1, -2h minus 1. Nothing else to simplify, so therefore this will be my answer. Notice that on your homework, you want to make sure that you are writing your notation. So you cannot just give me this as your answer. You have to make sure that you write down your f of h plus 1 equals -2h minus 1. So I'm looking for the entire notation as part of your answer. Sent in here, and even sent in here will be nice. And the last example for today. Go ahead and paste your graphs, copy it down, and then we'll start once you're ready. 2 parts. So let's start with the first part, f of x. I need to be able to find f of 2. So notice that we did it algebraically. And now we're going to do the same thing graphically. So in this class, you need to be able to have a very good concept. In order for you guys to do all the tests, you can't just memorize. Well, memorization is part of it, but understanding is what's going to make sure that you get an A or a B. If you memorize it, we'll end up with a C in the class. But the full understanding will give you an A. F of 2. So to give you a function, f of x, they don't give you an equation, they just give you the graph. So therefore, this is your x value. X value is 2. I'm looking for the corresponding y value. So that will be, what's the value? Place -2. And now we place in parentheses in there. So therefore, my y value is -2. Because this point here, your x value is 2, your y value is -2. Find f of -1. If you plug in a -1, what do you get back? You get this point here, which the y value is 1. And the one that you guys will get wrong is letter C. Find x if f of x equal to 1. See what you get, and then we can compare our answers. Got it? Excellent. So in this case, f of x is equal to 1. That means that the y value is 1. That means that we can get 2 points. We can get this point here and this point here. So what are the x values? So x value can be -1, or x value can be 3. Try this section, and then we can compare our answers. Go and pause it. Excellent. So in this case, find g of -4. So I'm going to plug in a -4, -1, -2, -3, -4. If I plug in a -4, I end up with +3 for the y value. Find g of 2. Remember, this is your x. You're looking for the y value. This is your x. We're looking for the y value. In this case, this is your y value. So you're looking for the x. This is your x. You're looking for the y value. So G of 2, 1, 2. What is the Y value? Notice that there's an open circle, so therefore that means that's going to be undefined. There's no such value, and that's why we leave it as open. You guys covered this type of graph, piecewise functions in algebra 2. Find x if g of 3, find x if g of x is equal to 3. This is your y value. We're looking for the x. X is, y value is 3. 1, 2, 3. Therefore, the values are from this section all the way to this section. All those points have a y value of 3. So therefore, we're going to place a set notation. So all the values of x, such as all the values are between -4 and -1. We can actually, let me just place as a interval notation instead. I don't have to use a and b, or I can actually go back. X, such as x is -4 all the way to -1, and all the values that are greater than -4, including -4, so be an equal sign, or all the values that are less than -1, including the values of -1. We're not going to be using this notation as much, but we can also write down as a set notation or interval notation. It will be from -1 all the way to -4, or from -4 all the way to -1, including both of them. So we can place it as this notation, which is equivalent to this, and all the values in between. So make sure to write down your summary. Have a great day, and I'll see you guys next time.